Okay, sorry for the late. And I think today we are going to introduce or discuss a little bit about the mathematical background. That's a very fundamental part. I think most of you have learned these topics before. If you never learned this, you can learn it now. I think it is not too difficult. And we just have some quick review on some mathematical fundamentals. Okay, yeah, this is just a sentence. I think that's interesting. Okay, a data scientist is someone who knows more statistics than a computer scientist. Okay, and more computer science than a statistician. Okay, and that means if you want to work on some data science, we might have some knowledge or background about the statistics or probability. Okay. I think most of you here are from the computer science department. So it would be useful that if you have some concept about the statistics, that'd be very helpful. All right, so let's start with the probability. Probability, I think this is from classical probability, and you might know this before. All right, so the probability is actually a formal framework to reason the likelihood of events. Okay, so I will use this example when we introduce or review the probability. Okay, so now suppose that we have two supermarkets, A and B, and these two supermarkets are located opposite to each other on a road, okay? All right, so each supermarket has 6 cloud cranes. We can see these shops, I think, everywhere. Okay, and each supermarket has 6 cloud cranes. So the totally we have 12 cloud cranes. Okay, so we might consider some experiments for knowing the number of cranes in use simultaneously for each supermarket. Okay, so this is what we would like to study, to experiment. Okay, so now you can remember we have two supermarkets, and each has 6 cloud cranes, and we would like to play around with the case that we would like to know the number of cranes totally in use at a particular time slot or simultaneously. Okay, so when we learn the probability, we first know what the experiment is, right? Experiment is just a procedure that can produce some possible outcomes. Okay. So in our experiments, we would like to know the total number of cranes in use simultaneously at some time. That could produce some outcomes. Okay, that could be the combination of numbers. Okay, so we might have this kind of combinations. Use these notations. Use these representations. We might say that the first number here indicates the number of cranes in use for supermarket A. And the other would be the number of cranes in use for supermarket B. So we can have this kind of combinations. So this just shows one possible outcomes for our experiment. Okay. All right. So in the experiment, it just produces possible outcomes. So if we collect all the possible outcomes, it would be a sample space for our experiments. Okay. All right. So in our example, because each supermarket has 6 cloud cranes, right? Yeah, cloud cranes. 6 cloud cranes. So the number of possible outcomes in our experiment would be 49. So we might see all possible combinations of these results, of the experimental results. Okay. So 2, 4 could be one possible outcomes. So if we collect all the possible outcomes of our experiments, we might have what we say the sample space. They totally have 49 possible outcomes. This table shows the possible outcomes, okay? Because for each supermarket, we might have 7 states, okay? The 0 means no cranes is used as a particular time slot. Okay, the 6 means that all the cranes are in use in some supermarket. And we do the combination on these 2 supermarkets, we have this totally 49 possible outcomes. Okay. So if you want to know the total number of cranes in use simultaneously for these 2 supermarkets, we just do the addition on these 2 numbers of each pair. Okay. So for this pair, 2, 3, that means we totally have 5 cranes in use. 5 cranes in use. Okay. Right. So just remember this. Okay, so now after we know what the experiment is, what are the possible outcomes for experiments and the idea of the sample space, we might define some events on some set of outcomes. Okay, so an event here we just say an event is just a specific subset of outcomes of an experiment. Okay, so let's just borrow the idea of the set. I think most of you have know what the set is. Okay, in mathematics, when you learn sets, we might have subsets of a set. Okay, so for the subsets, we might have in probability here. If we collect all the possible outcomes, we say that would be a sample space, right? It's actually a kind of set. Okay. So we can define the events, use what we say the subset, okay, to be an event. All right, of course, we can have some specific definition on that, and it will produce a subset of the outcomes. Okay, so for example, if we like to know the total number of cranes in use is 4, yeah, that's what I mentioned. If we can just do the addition on these 2 numbers of each pair, that will indicate the total number of cranes in use. Okay, so here, if we want to know the total number of cranes in use is 4, that means we can check all the possible outcomes and do the additions on these 2 numbers, and we take the number equal to 4. So we take the case of the number of being 4. So we might see if the events, if the events says that we would like to have the total number of crayons in use is 4. We might check, I think could be this line, right? 0 plus 4 equal to 4, and 1 plus 3 equal to 4, and 2 plus 2 equal to 4. So we might pick up these 5 pairs, or 5 outcomes. Okay, so the events would be the subset of all the possible outcomes. We have these 5 outcomes in this event. Okay. All right, we could define different events. Okay, we may have different subset of the outcomes. Okay, so we might define like at the most 1 crayon is in use at each supermarket. Okay, at most 1. That could be no crayon is in use, or just 1 crayon is in use. So for each supermarket, we might have 2 possible cases. And we do the combinations. We might have the event as this subset of the outcomes. Okay, 0, 0, 1, 1, 1, 0, 0, 1. Okay. All right. Similarly, we can have the other events. Here just says that if we would like to have the event that the total number of crayons in use is 7 or 11. So we might consider the event that total number of crayons in use, or the total number of crayons in use is 11. So we might consider these 2 events, and we take the union of these 2. So we might check. You can check for the total number of crayons in use is 7, could be this line, I think. And for the 11, could be these 2. Okay. And we do the union of these 2 subsets, okay, because we define it as an OR. Okay. All right, so we might have the set like, the subset like this. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes. Okay. This is an example for the events. All right, so for each outcomes, we just see the combination or the possible outcomes, but we haven't defined or we haven't give the probability for the outcomes. So here just give a formal definition about the outcomes, But you can just look at this, the probability as a function. Okay, that maps the outcomes to a real number, and this real number is smaller than or equal to 1, or greater than or equal to 0. Okay, that means some number in between 0 and 1. Okay, so in order to define the probability over an sample space, or if we define the probability of an outcomes, we might associate the outcomes with a real number, and that number would be between 0 and 1. Furthermore, the other conditions is the sum of the probabilities of all outcomes is equal to 1. Okay, this is a very important condition. Okay. In general, I think maybe in the future when you work on the probabilities, you might focus on the first conditions and you might forget the second important conditions. Okay, so if you would like to see whether the functions you give for the sample space is a probability, the first things you need to illustrate that for each outcomes, we associate the real numbers, and that number is in between 0 and 1. Okay, that will be the first property you need to check. And the second property you need to validate would be the sum of the probabilities of all outcomes is equal to 1. Okay. This second property should be also validated in order to say that the function you associate with the outcomes would be the probability. Okay, so I think in the future when you work on some things, and you might focus on the first probability too much, and you forget the second important property. Okay. All right. In our example, we just assume that all the outcomes are equally like. So here, this will be 49 possible outcomes. And for each outcomes, it happened equally. So we'll give all the outcomes are equally like. Because we have 49 outcomes, so for each outcomes to occur, the probability would be 1 over 49. All right, so for each outcomes, we associate this number. And because we assume that all outcomes are equally like, so if we do the summation over the probabilities of all the outcomes, they're equal to 1. Okay. So this would be the easiest case that you can define the probability over the sample space. Okay, this is what I mentioned. I think afterward, maybe in the future, the best probability. Sometimes we forget this property in order to say that the function is the probability. Okay. All right, so after we define the probability of an outcome, we have introduced what the event is, right? So we can furthermore define what the probability of an event, okay? And if you remember, the event is actually a subset of the all possible outcomes. So the probability of an event can be simply defined as the sum of the probabilities of the outcome in that event. Okay, so we can, maybe we can write it like this. Okay. Oh, wait a minute. Let me get back here. We use the notation here to indicate the probability of an outcome S. Okay, this P indicates the probability. Okay, the probability of of outcome S. Okay, so for the probability of an event, we just simply do the summation over the probabilities of the outcomes in that event. Okay, we can simply use this way to define the probability of an event. Okay. It's just a quick review. I think most of you have learned this. It's actually just the concept of the functions and the subsets. Okay. Just combine these two. And you can look at the outcomes as, or the sample space as a set. And if we talk about the probability, you can think of that the probability is actually the function that maps outcomes to real numbers. And we have some condition, or we have some constraints on the real numbers. All right, so here just give you another idea, because this just use the notation from set, okay, the complement of the set. Let me just give you the picture here. This would be all the universe, okay, or we say the sample space. And the E is actually a subset of the sample space. And the E bar says it is a complement of these events, of these sets, okay. And if we take the union of these two, E and its complement, we can get the universe, the whole space, okay? So if you would like to derive the probability of an event, we can divide it reversely, okay? If we know the probability of the complements of the event, we might get the probability of an event, okay? This is just another way to derive the probability of an event. Okay, so remember this, the first example when we talk about the event. If we like to know the probability of the event that the total number of crayons in use is 4, that could be because we have 5 outcomes in that event. So the probability would be 5/49. 5/49. That means we have these 5 outcomes, okay, to the whole sample space, the number of possible outcomes. So it will be 5/49. Okay. All right, so after we define the probability for the outcomes and events, we might see this a lot when we learn probabilities or statistics. Okay, that would be the random variables. Okay, actually, the random variable is another function that okay, is a function on the outcomes of a probability space. Okay. Okay, so we might that means we can associate the outcomes with some numerical numbers to the possible outcomes. Okay, so for example, this would define a random variables. That means the total number of crayons in use simultaneously in these 2 supermarkets. Okay, so we may have some association on this kind of description. Okay, so this says that we consider the number of crayons in use simultaneously for these 2 supermarkets. Okay, so we just count the number of crayons in use and based on all the possible outcomes. So for here, the VAB says that we just do the addition on the number of crayons in use for 2 supermarkets. Okay, so we might have these random variables. It could be a combinations here, and we might check the total number of crayons in use. We can define it like this. Okay. Okay, so we might define the random variable like this. Okay, after we know what the probabilities and the events are, and we might see these random variables. Okay, it's actually a numerical functions. Okay, over the outcomes and okay, so this will be the example, right? It just says that we would like to, the experiment we did for our example, we would like to see the total number of crayons in use simultaneously. Okay, so we just do the addition on these 2 numbers. Okay, and all the possible values for the random variables here in this example, it could be 0, and the maximum number could be 12, right? Because we have 2 supermarkets, and each has 6 cranes. Okay. Okay, so we can do the addition on the pairs. Okay, we can define the random variables on this. Okay, and because for this kind of definitions, for example, if we would like to count the total number of cranes in use is 6. Is 6. 6. Let's go back here. Let me check whether I have one or not. Okay. Is 6 would be this. Would be this. This diagonal, I think. Okay. 0, 6, 1, 5. So the total number would be 6. Be 6. Okay. So how many outcomes will be on these diagonals? There will be 7 outcomes. 7. Okay. So for this case, we have 7 possibilities. Okay, we have 7 cases, 7 outcomes for these conditions. Okay, these conditions says the total number of cranes in use is 6. Is 6. Okay, that means we might have 7 outcomes. Okay, that will support this condition. Okay, so the so we may associate this random variable with the probability, like 7 over 49. 7 over 49. That would be 1 over 7. That would be 1 over 7. Okay. Because for this kind of variables, we might have 7 outcomes. 7 outcomes. Okay. So for these random variables, when the number of cranes in use is 6, the probability would be 1 over 7. 1 over 7. Okay. On the other hand, if we look at this one, okay, there's only 1 outcomes for this random variables for this value when the total number of cranes in use is 12. Okay, the probability will be 1 over 49 because there are only 1 outcome. That'll be this one. Okay. Again, this is another concept of the sets, of the sets. So in general, when we learn probability, we usually learn with the concept of sets. Okay, that'd be easier for us to have some results or to think. Okay, and this just shows the possible value for our defined random variables is here. Okay, 0 to 12, 0 to 12. And for each values, it has some outcomes. It has some outcomes. So for this example here, that means the total number of cranes in use is 6. Okay, it has 7 outcomes here. And if we take the 9 here, the total number of cranes in use is 9. We have 4 outcomes. We have 4 outcomes. Okay, so do not mix up with the probability and the random variables. Okay, these are 2 totally different things. Okay, and with these random variables, we also can have the idea about the expected value. Expected value. Okay. Sometimes, if we look at the expected value of random variables, this would be the formal definition. Okay, its corresponding value, or the value associated with the random variables, times its probability, times the probability. And we do the summations. We might derive this expected value. Expected value. Okay, this would be the expected value of the random variables. what I mentioned here is this is the formal definition for the expected value of a random variables. If you look at these functions, you might think it's actually just weighted functions. Sometimes we would like to calculate some weighted values. We might use the similar idea here. Okay. All right, so we give different weight for each probability. Okay. In that case, we might have the expected value for some random variable we have defined. Okay. All right, so these will be the random variables and expected value. Okay, and we might see the random variable later, maybe. Okay. All right, so let's have a 10 minutes break and move on for the next slides. Okay, the 10 minutes break.